All right, so last time we started to talk about the how we can prepare our data to do vulnerability analysis or fragility analysis, because over the last week we were just talking about how to develop fragilities. Then we know how to develop fragilities, either 2D or 3D, and I told you that the concept is kind of similar for all hazards and mostly for all structures. You need to start by components, you need to find what uncertainties that you are dealing with, propagate the uncertainties. We use the process that we use generating simulations. It's called Monte Carlo simulations. Maybe you can use different, I don't know, there's Latin hypercube simulations, there's different ways that you can we didn't cover all the type of simulations generation, but we only, the way that we did rand, normal distribution, all these stuff, it's called Monte Carlo.
Professor, can you just
The lights. So this, we finished the fragility. The last time I start showing you how to prepare the data for fragility or vulnerability analysis at the community level. So we start importing the shapefile, like here, that's the building, and I showed you how I can download it from the National Structure Inventory. You can download it from any source. Like before the National Structure Inventory, I used I used to collect the data by myself, like going to Google Street Map View, look at the buildings and identify the archetype from the Google Street Map View and assign an archetype for each building, looking at the foundation, roof, walls, number of stories, and all these stuff. Right now we have more data, so we need to work smarter, not harder. So we start like to have this data, and then I showed you something called a mapping algorithm. Did I did that last time? Do you guys remember? Like it was like a MATLAB code, something like this. I told you it read the information in the shapefile that you have. It read the occupancy, number of story, foundation type, and I told you it reads some other stuff that we don't need, maybe the value of the content, the value of the structure. We're gonna need this data later, but not right now. But we need, mostly, we need the number of stories, we need the foundation type, we need the building occupancy. We need to know either this building residential or commercial. And if it's residential, we need to know either 1 story or 2 story, and either on a slab on grade foundation or crawl space foundation, so that we can know is it archetype 1, 2, or 3. All right. So once we do this, once we read all this information, I was trying here to map 2 different types of archetypes, so one for flood and one for wind. It's the same process, but the thing is, the team of researchers who developed the wind archetypes, they developed a lot of archetypes, more than the flood. The flood like is 15, the wind is 19, the earthquake is a lot. Okay, so the main mission that I was trying to do with this mapping algorithm, the way that the National Structure Inventory was developed, it was developed based on HAZUS. Have you guys heard about HAZUS? HAZUS is a vulnerability analysis software developed by FEMA. So basically FEMA developed HAZUS long time ago, and they started by earthquakes. And when they do vulnerability analysis, you have to have an archetypes. And they developed 33 building occupancy. They didn't call them archetypes, they called them occupancy or building types. So like if we go back to the shapefile that we had from last time, you will go here, you will find something, it's called occupancy type, this one here. That's, it didn't say it's HAZUS, but all these occupancy types are from HAZUS. Try to go to Google and search HAZUS building occupancy types, and then you are gonna have like a manual that has HAZUS, and there are 33 different building occupancy types. And you are gonna find a description. What is N1 and N2? That's being industrial building. There's 1, 2, 3, and 4. They have different type. Okay. Same thing with the commercial, with the residential. They have 1. They have residential 2. So you have multiple of them. Okay. So the thing is, I don't want to work with the HAZUS occupancy. I want to work with my occupancy, with my fragilities, because HAZUS has not a fragility function. They have something called stage damage functions. And the stage damage functions, it's less, from my perspective, it is not as accurate as ours, or it's a different approach. It's not probabilistic, it's deterministic. It's based on data collected from the field, and some of them are based on engineering judgment. And basically this function is one line, it's like a loss function. It tells you how much losses that this building is gonna have if it got exposed to a flood depth 2 meters. It tells you it's gonna lose 20% or 30%. It is not a fragility that can tell you what is the exceedance probability of a specific damage or state, okay? So we wanna migrate, or we wanna shift from these 33 to our 15 building archetypes. So I'm trying to match these 33 with our 15. So I use a bunch of data to do this, and I showed you that I have a code here that I developed. It reads the occupancy type, the number of stories, the foundation type, the foundation height, and all this information. And then I start mapping. Like here, if the building is agriculture, assign this archetype. If the building is commercial, assign this archetype, okay? It's like an if statement. It check if 1, 2, 3 satisfied, assign this. If 1, 2, 3 satisfied, assign this. So I'm checking if this building is matching the criteria that I have, I assign a specific archetype. That's what we have done last time. At the end, once I'm done with all the if statements, like all this code is a bunch of if and else if. And then at the end, I would regenerate the shapefile with a new fields are called, one of them, wind archetype and flood archetype. So basically, you input a shapefile to a mapping algorithm, you get a new shapefile with the mapped archetype. It tells you this archetype is 1, or 2, or 3, up to 15. If we are talking flooding, if we are talking wind, it's gonna tell you this building is archetyped from 1 to 19 if we are talking wind. That's what we were doing last time. What is the next step? So right now, we know each building has a fragility or has an archetype, because when we say a building has an archetype, the archetype is attached with a fragility, because we already developed this fragility for this archetype. So the next step is to know what is the flood depth at each one of these buildings. So we need to have a hazard map. I'm gonna give you the hazard map. Like on a Google Drive that I'm gonna share today.
Professor,
Yeah.
I want to ask you about the MATLAB code. I don't think like we discussed it in the last time. The last time we were talking about ArcGIS, how we bring the raster maps and everything inside there. And you said you're gonna discuss the command in this lecture.
Yeah, the damage I'm gonna do it today, but I'm just showing what we did last time, so how we connect.
Oh,
But
okay.
what do you mean the MATLAB code for what? For the
I mean,
mapping?
yeah, because I saw flood depth and wind. Like, why does it have wind inside?
Well, I was doing the wind if we are gonna do wind like after a few lectures.
Oh, okay. So
Yeah, but the mapping algorithm you're not gonna have to them. Like I'm gonna give you the data mapped, or I'm gonna give you the code to do the mapping.
Oh, okay.
But you are gonna develop the damage, the one that I'm gonna explain today.
Oh, I thought you meant this one. Okay.
No. I'm gonna do it today. So I'm gonna give you here a data for the community that we're gonna solve today. So we're gonna have the boundary of the community. I'm gonna give you the buildings, right, without mapping. And here, this is all shape files. And then I believe I give you the map too, so maybe you don't have to do mapping. And I give you the building boundary in lines, and I give you the hazard map, like here, the 100-year event. Okay, so I give you the mapped buildings. You don't even have to do the mapping, but I'm telling you the process. If you want to do the mapping, the thing is, you are not gonna get the data on a plate of gold. Like, so you have to do process to see this data to prepare it for the analysis. Okay. All right. So the thing is, we have done the mapping and we know what the archetype for each building. The second step is to know the flood depths. I showed you last time that you are gonna download this hazard map and download the mapped buildings, and you have them in GIS, and try to extract, like if you zoom in, try to extract the flood depths at each one of these buildings. And that's what we stopped at last time. Like last time I showed you from the mapping, we had a new archetypes for the wind and the flood, and then we are trying to figure out what is the flood depth. And then we extracted this field. And I told you that this flood map is in feet, from 0 to 15 foot. Okay? So we knew the flood depths in feet. So, and then I told you that we need to convert it to meter. Why? Because the fragilities that we have are metric units, not in American units. So to do this, it's very easy. You are gonna add a new field. And I'm gonna name this field, like here. I'm gonna name it, let's say, D meter, and I'm gonna put 1, and I'm gonna change the data type to double, because we're gonna have numbers, and I'm gonna make it as a numeric, and then I'm gonna say okay, and then once I'm done, not hearing anything. Oh yeah, sounds like it didn't. Okay, so it's good. It tells us the volume, and then once I'm done, I'm gonna say save, and once I save, it's supposed to show up, the new field is supposed to show up in the shapefile here. Okay, so I can close this now, and then I'm gonna go back to the field that I just created, and it has zeros because I didn't do any mathematical operations on this field. So the thing is, I want to make this field the same like this, but I want to change the unit. So I'm gonna right click on this field, and I'm gonna say calculate field, and I'm gonna calculate this field based on the numbers here. Do you guys know the conversion from feet to meter?
Yes. Yeah. Multiply by 13048.
8.3048. So I'm gonna basically say that all the numbers in this field equal the number in this field multiplied by 0.3048. All right, it's taking some time. And once I'm finished with this step, so right now I know what the archetype for each building and what fragility for each building, and what is the flood depth for each building. So basically, all what I need right now, I need a code that can draw or read the fragilities of each building, because right now I don't have the fragilities in this shapefile, I only have the archetype. So I want a code, MATLAB code, that can read the 15 archetypes fragility and try to connect each building with its fragility, okay? And read the flood depths for each building, all right? And then once it reads it, goes in the fragility, calculate the probability of damage, and put it in another field. That's what I need to do damage analysis. And I need this code to repeat the same process for every building, right? So basically you need a for loop that is gonna go say, if this building archetype 1, big fragility for archetype 1, read the flood depths of this building, go in the fragility, do some interpolation to get the probability of damage. Once you are done, go to the next building and do the same process until you finish all the building and then end. That's basically all the damage analysis code that we're gonna do is doing, right? Mm-hmm. Same thing for the losses. Go read the building archetype from this field. If the building is archetype 9, go pick the loss function for archetype 9. And then read the flood depths for this building and go in archetype 9 loss function, find how much losses and put it in a new field. Once you are done, keep looping until you finish all the buildings. Once you are done, end, and then give me the final shapefile. That's what the damage process is doing, right? So basically I connect this fragility with the building, and then you read the flood depths, and then you get the damage, write the damage for this building, continue the loop until you finish all the buildings, and then write a new shapefile with the new results. Okay, so here I'm gonna convert the damage, so I'm gonna say that this is equal to the flood depths in feet multiplied by 0.3048. And then I'm gonna say okay. And by the way, I did this process before, but I'm just showing to you, like if you look here, you'll find I already have the same flood depths already here. and this is the flood depth in meter, so it's gonna be here. So it's just showing you the process again. All right, so let's jump back, to the coding, how we can write a MATLAB code. All right, that's the MATLAB code for the damage analysis. The idea is the one that I told you about. We need to read the shapefile and link the shapefile and the buildings with their archetypes, and then analyze for damage, read the depths, go in the fragility, get the probability of exceedance of each damage state. So what I'm doing at first right now is just reading the information that I need to generate the fragility. I want the MATLAB code to read a bunch of information for loss functions, for fragility functions, for all of these things. Okay, so the thing is we are gonna do some loss analysis. So I'm giving the MATLAB the loss functions. So I'm gonna read an Excel file. This Excel file, this one, I'm gonna open it for you. Open outside MATLAB. All right, so there's an Excel sheet that's called Building Archetype Data 2D. That's the Excel file. And there's a sheet is named Loss 2D, this one. What is inside this sheet? Inside this sheet is a table that has, first column is for archetype 1, second column is archetype 2, 3, 4, 5, up to 15. And each row is the flood losses at a specific flood depth. Like let's assume that this is archetype 1. So I'm giving the MATLAB code, what is the value here, what is the value here, what is the value here, in column 1 for archetype 1. So I'm giving the MATLAB all the loss curves for all the archetypes. All right, so let's see it here. All right, this is the one, and I'm reading this one. Can you see? Look at this. Column number 1, it's called F1 loss 2D. F2, that means archetype 2, F3 up to F15. And if you plot this with the flood depths, this sheet, the flood depths from this sheet is gonna give you a loss function. This one is gonna give you another one, and another one, okay? So I'm reading the loss function because I wanna do damage analysis and loss analysis. Do you guys remember when we have a fragility that gives you damage and a losses that gives you dollar loss? So that's what I'm trying to do. Okay, that's the first Excel sheet. The second one,
the loss is the replacement cost, or
no, this losses is percentage of the total building market value. Okay, so if I went all the way down, you will find that all of them are approaching the 100%. See?
Oh,
So that's the percentage of the total building market value. The thing is, when I did the loss analysis, it wasn't dollar value. It wasn't percentage because everything I put it as a dollar. Do you remember when we have the unit replacement cost?
yeah.
But the thing is, I thought about it that the dollar value keep it changing every day or maybe every year. I developed these functions in 2020. Right now the price is completely different. So at the end, I divided the losses by the total value of the building. Like let's say the losses at a specific flood depths was like 10K, right? And the total building value for this building was like 300K around that time, right? So what I did, I divided 10K over 300K and I got a percentage. So that's what I did. Because if the price changes, you just multiply by the ratio, assuming that all the values of the building are increasing linearly, like no one is increasing very high and one increasing a little bit. That's the assumption. So basically, if I want to be accurate, I need to re-enter the values of each content again and redevelop the whole thing. Okay, but I didn't do that. I just assumed the percentages. All right. Okay, so that's for the losses. The second thing that I was reading is the depths. So I'm reading the depths because I have the depths in a separate sheet here. So I have the flood depths here because that's the x-axis. So the first Excel sheet has the y-axis of all the loss functions, and the depth has the x-axis. So if I want to plot the losses, I need to use two sheets. The sheet that has the depth for the x-axis and the sheet that has the y for the y-axis. Okay, so I read this separately. Okay, and here I'm reading the damage state log normal parameters. Do you guys remember the, I think it's open here. Let me open again. Do you guys remember when we had the fragilities and we have the damage state have the lambda and exceed the log normal parameters for each archetype? I told you we're not going to use the x, y coordinates. We're going to use the fitted one, and the fitting, it gives you lambda and xc, and moving forward, we're going to use lambda and xc to generate the fragility. We're going to give lambda and xc to a function here, like let's say log normal function, and then we are going to give it lambda and xc for all damage state, like from damage state 0 to damage state 5. And then this function basically is going to give you how's the fragility look like, right? So I need the Excel file, this Excel file, I want to give it to the MATLAB to read it, and then I'm going to use it to develop the fragility. So this is the Excel file, has the lambda and xc for each damage state and for each archetype. Here's archetype F1 up to F15, and here's lambda and xc, the logarithmic mean and the logarithmic standard deviation. All right, then I will go back to MATLAB. I'm reading also something is called the damage state replacement cost for each archetype. What does that mean? All right, there's another way that I want to calculate the losses with, different than giving the losses directly to MATLAB. I wanted, if you guys remember, when we have the fragility gives you the exceedance probability of each damage state. I want to convert the damage to losses, not getting to the losses right away. So basically, I have for each archetype what the value of each damage state. The value of damage state 1 is like 0.03. The value of damage state 3, because I calculated all the content that contributes to each damage state. So if you go to this Excel sheet that is called damage state replacement cost. All right, let's find out. Can you guys see it? Oh yeah, here. I'm gonna open outside MATLAB. I believe it's sheet 1. Can you see this? This is, I'm giving the value, the percentage value for the replacement cost of each damage state. Like damage state 0, that means you have 2% damage, or 70% damage if it's damage state 3, or damage state 4 is 100% damage, okay? And I did this for all the archetypes. It's so different from an archetype to another because I did detailed cost analysis for each one of them, all right? Okay, so I give all these numbers. Okay, all this data was in a bunch of Excel files. And the thing is, when we do damage analysis or when we do programming, we need to prepare this data in a way, in matrices that help us do the analysis. So I start organizing this data in matrices. Like I start putting the replacement cost analysis in a matrix. It's called the archetype replacement cost. Okay, this archetype replacement cost is gonna have, like on x-axis is gonna have the archetype number from 1 to 15, and then I start assigning from the Excel sheet the percentages. Like I said, like for example, the numbers in field from 2 to 5 is for archetype 1 or archetype 2. The numbers in so here, let's actually run it and see what we are gonna get. All right, I'm gonna run this section. Let me run the whole code. Change the folder. I'm gonna run it section by section. Clear everything. Right now I'm reading the data from the Excel files. and look at this one. This is a matrix. It's called archetype replacement, archetype rep, and it reads the values from the damage state replacement cost, and it goes like row by row. Like here it says, in this field, in this in row number 1, put the archetype replacement cost from this file, all the data from 1 to 5. Like here, from 1 to 5, put them in archetype 1. From 6 to 10, put in archetype 2. From 11 to 16, put in archetype 3. So I'm just like reading and arranging the data. So here, this is the damage state replacement cost ratio with all the information. I only need the ratios here. So I'm saying pick column number 5, this column, and pick the number from 1 to 5 and put them here. So if I run this code, and then it's gonna generate a new matrix. It's called arcrep, which means archetype replacement cost, and it's gonna have 15 row for the 15 archetype with the replacement cost on the for each row. All right. So I'm just preparing the replacement cost matrix. All right. The second one, I'm reading mu and sigma for each archetype. I'm doing the same thing here, and I'm reading the information here and also arranging them in MATLAB. Like right now, this is an Excel sheet. I want to convert it to a matrix that has on the x-axis something and on the y-axis something. So I'm putting all the mu and all the sigmas in separate matrix. Like look here, I'm putting the mu for damage state 0 in a matrix that's called damage state LN, mean like abbreviation for log normal parameter, and put in the first column here from 1 mu damage state 0. Okay, so the final matrix is gonna be called mu, and it's gonna have damage state like the column number 1 is gonna have damage state 0. Like look here, mu is having 15 row for each archetype, and it's gonna have 5 columns. Each column has the mu for damage state 1, damage state 2, 3, 4, 5. 2 archetypes that only have values in 1. And by the way, be careful. 1 means damage state 0. But the thing is, there is no way that we can call a column number 0 in MATLAB. MATLAB starts from 1. So 1 is gonna be 0, and 5 is damage state 4. We don't have damage state 5. We opt to damage state 4, so keep this in mind. And we only have 2 archetypes that has values in damage state 0. That was archetype 1 and 3. The other, they have nothing, so it put NaN. That means I don't read any data, or we put a slash or something. The thing is, I can't put 0 because 0 is a number. And if I put number, that means it can generate a log normal distribution. Okay. So when I came here, I want to generate the fragility for all these 15 archetypes. So right now I have the mu and I have the sigmas. Like if I go down, I have the sigma for each one of these archetypes. Okay, so I have the mu in a matrix and the sigma in a different matrix. Okay. Then here I'm developing the fragilities for every one of them. So I'm saying I want to develop the fragility for each archetype here from 1 to 15. And the thing is, I'm gonna develop them for damage state from 2 to 5. That means from damage state 1 to damage state 4. Why I didn't make this one? Because if you make this one, the MATLAB code is not gonna run. Because here there's no numbers. So it's gonna crash. Why? Because it's gonna read NANs and can't handle NANs. So I started to do it from 2 to 5, and I started doing these 2 separately. Okay, at the end. All right. So from 2 to 5, and then at the value of each flood depths, because I give MATLAB flood depths is, I asked MATLAB to find out what is the value of the on the CDF for each flood depths, for each mu and for each sigma. Like let's say we pick archetype 1, like let's say archetype 1, and we are gonna go for K2, that means damage state 1. I'm trying to calculate for depths equal 0.01, 1 centimeter, try to find what is the exceedance probability, or what is the value in the CDF, given that I give you what is the value of lambda and XC. Because lambda and XC can help you to draw the curve. So redraw the curve, number 1, and number two, take the flood depths and then calculate what is the value on the y-axis. And once he calculates the value on the y-axis, he's gonna put them in this matrix. This matrix is gonna have what is the probability of exceedance, each damage state, like K is here, for each archetype I. Okay, so it's gonna be a 3D matrix. It's gonna have on the x-axis the flood depths. On the y-axis is the building archetype. On the z-axis is the damage state. And we are gonna have this in one matrix. So once it's run, and then I start doing the archetype 1 and 3 separately because they are the only ones that has damage state 0. And I start putting them here alone. So I did the log normal CDF separately. Okay, we run this one, then you can, actually I can plot this. Let me get the plot function. Yeah, here, I'm gonna copy it. I'm gonna put it in that code. Let's put it here. All right, this is a function that can plot these curves. So basically I'm saying for each archetype and for each damage state, plot a figure, and this figure is I. That means, can you see that? The for loop starts from I equal to 1 to 15, and here the figure is I. Can you imagine how many figures that we're gonna plot? 15, right? Because it's gonna loop for archetype 1, so it's gonna put I equal 1, and then once it's finished, it's gonna draw a curve for archetype 1. Then it's gonna start a new loop, and it's gonna make another figure. If you put this one, it's gonna make all of them, all the building fragilities in one figure. So I'm making the MATLAB to generate a single figure for each archetype. Okay, so let's run this code and see how it's gonna run. I'm gonna also scroll through it so you guys see what is written inside it. First I draw the damage states from 2 to 5, and then at the end I said for figure 1, because that's for archetype 1, plot this, and for figure 3, plot this. Because if you guys remember, we have archetype 1 and 3, they have damage state 0. So I added 2 curves to each one of them separately. Okay, so here I'm gonna run this MATLAB code. Let's see. So it's supposed to be right now starting reading the numbers. That's gonna generate figure 1 in the first loop. You draw everything, and once it's finished with archetype 1, it's gonna generate another one, because each loop generates a figure. So right now I know it's right now in loop number 3. Now shifted to loop number 4, drawing the fragility number 4, number 5. And as you can see, all the fragilities are smooth. Why? Because we give him the lambda and XC for each one. It's not the raw fragility that are like broken or something. And definitely put some annotation, like if you look here, I put legends, damages state 0, 1, and 4. I put the fonts, I put the color. Okay, so at the end, it runs these 2 curves, 1 and 3, to put the damage state number 0. So once it finished the whole 15, he came down, he found that there's another one to draw for figure 1, another one to draw for figure 3. So that's the one that I have done at the end. And then you will end up with all these fragilities. This one, how it looks like. All right, okay. To be honest, I don't want to draw them. Like when I'm running the damage analysis, I'm just drawing them for you to visualize. That's why I didn't have them at the end. Because when you run the analysis, you want to get results. You don't want to see drawings. I only need drawings when I publish papers, so I need to show off fragilities or something like this. So that's why I drew them for you. Okay, so let's go to the next step. So right now, we read all the fragilities. Okay, all the fragilities are inside, all the loss is inside. So what is the next step? I need to read the shapefile that has all the building's data. because right now this MATLAB code doesn't have any buildings data. So I'm gonna read the shapefile and try to connect these fragilities with the shapefile. So look at this. Here, I started reading the shapefile. How to read the shapefile in MATLAB? I'm not sure how smooth it's gonna go with you because I believe maybe you have to download something, it's called a mapping toolbox from MATLAB, so that you can use this function. It's called shape read. Shape read, it reads the shapefile, but it has to be in the same folder, and then you put the shapefile like this, and then you hit run. It's supposed to read the shapefile that you have. Okay, so once you run this one, it's gonna take a little bit because we have like a lot of buildings. And then once I read the shapefile, I don't need all the data in the shapefile. The shapefile have the building lot zone, the building ID, it has a lot of things. I only need a few information from this shapefile. I need the flood archetype and I need the wind archetype if I'm gonna do wind damage analysis. I need the foundation height to get the first floor elevation. I need the building value, the ground elevation, the building area, the value of the structure, the value of the content, the value of the vehicles, and definitely the flood depth. And basically the flood depth in meter. I don't need the feet one, unless if I have everything in feet, but I read them. So that's the data that I only need from the shapefile. That's why I read the shapefile and I extract the columns that I'm gonna work on. So basically, I'm taking the columns that are in the shapefile with their names, so I'm using the function that's called extract field. So extract field basically, it goes to the shapefile that you name in the first letter here, S, the one that we introduced as an S here. Can you guys see here? So I'm saying take the extract field from shapefile S and the name of the field is that one. Okay, that's the extraction. So right now it read the shapefile. Look at the shapefile. It has different matrix type. Look here in the workspace. By the way, if you guys are new to MATLAB and don't know how to show these areas, you just go to YouTube. How can I show workspace in MATLAB? How can I show variables in MATLAB? So it's gonna tell you how from the settings to show all these fields. To be honest, some people like to have this here, so try to organize the MATLAB the way that you want. Anyway, all right, so look at this. All the matrices that we have this logo, like this image. That means it's like a matrix. The numbers is like 2D matrix. This one, it's not. It's called a structure. Like it's a geostructural data. So if you open them, if you open this one, it's gonna show up something like this. It's gonna show you the fields. It's gonna show you the same thing like you are visualize a shapefile. All right, it doesn't put NaN if you have text. It puts everything that you have, numbers, everything. All right, so next step, I'm gonna do the extraction. I'm gonna run this section. But let me close this one because it's consuming my laptop memory. I'm gonna run this section. So I'm extracting the fields. Right now, I'm extracting the fields. The thing is, I can't work with this S shapefile. I have to convert it from a geo information to normal vector that I can do operation on it. That's why I did the extraction. Once I did the extraction, I did some elevation analysis. Do you guys remember when we spent one lecture drawing a building and showing you the ground elevation, first floor elevation, all of this information? So here, that's what I'm trying to do. I'm extracting, if I have a water, like I define a matrix that's called water surface elevation. I'm gonna calculate something that's called water surface elevation. And from the water surface elevation, I'm gonna calculate depths measured from the first floor elevation. And sounds like I did everything here in feet, and I believe I converted in meter at the end. So I have everything in feet here. And so I have the the depths FFE and the building FFE. So the DFFE means the flood depths measured from the first floor elevation. Building FFE, the first floor elevation of the building. So maybe the depths measured from FFE here and the first floor elevation measured from FFE here. And for each building, I'm trying to calculate what is the water surface elevation, what is the building first floor elevation, and what is the flood depth measured from the FFE. Look at this. Water surface elevation is based on the ground elevation plus the flood depth on top of the ground elevation. Because usually when, I need you guys to like distinguish between elevation and depth. Elevation is gonna be like hundreds, or gonna be a big number. That means the flood elevation is measured to the mean sea level. Depths, that means it's an absolute value. Okay, so what I have, let's say I have a ground elevation is like 120. That's the ground elevation measured to the mean sea level. And I have a depth of flood equal to 6 feet on top of this elevation. That means the water surface elevation measured to the mean sea level is at 126, right? So that's what is the water surface elevation. Okay, next step, I want to calculate the building versus the floor elevation. So same thing, I know what is the ground elevation, all right? And I know what is the foundation height. So let's say that the foundation height is 3 foot and the ground elevation is 120. So the building versus floor elevation is 123 foot. Let's draw it here. Let's say that this is my building. All right, that's the ground. And this ground let's say this ground is something like this, and this is the mean sea level. The mean sea level here is 0. The elevation of the sea is 0, right? But your ground elevation measured to the mean sea level is like 120. Measured to the mean sea level. That's what we call elevation. So then you have what is the flood depth measured here is like h is equal to 6 foot. All right? So basically you can get the water surface elevation. By the way, this is depth, but this is elevation. Elevation measured to the mean sea level. So the water surface elevation is going to be 126 foot. Right? You guys got that? All right, but this is the water surface elevation. This is the water height, or the water measured from the ground elevation that we got from the map. I'm interested in to get this. What is the water that's above the FFE? But to get this, I want to know, where is that? What is this? If I know this height, which is, I told you, like 3 foot, so I can get something that's called FFE, the first floor elevation. It's going to be 3 plus 120 is going to be 123, right? Then if I have this 123 and I have this 126, so this is going to be 3 foot, the difference, right? That's what I'm trying to do here. I'm trying to calculate what is the water surface elevation, right? I'm trying to calculate what is the building first floor elevation, and if I know the first floor elevation and the water surface elevation, I subtract them and get the water depth measured from the FFE. That's what I did here. The depth measured from the FFE equal to the water surface elevation minus the building first floor elevation. All right, so I did this process for every building. Next step is, oh yeah, here. The thing is, once you do this process, you are gonna end up with negative values in some buildings. Like some buildings are gonna have flood depths here. Like the water is here. That's the water surface elevation. So when you subtract the water surface elevation, which is like, let's say 121, minus 123, you will end up with negative 2 feet. So that means the water didn't make it to inside the house. So the thing is, when you run the damage, the fragility, we don't have negative numbers. So the MATLAB code is gonna stop. It's gonna say, I can't interpolate. So your whole MATLAB code is gonna, it takes me like when I was running this code a little bit to figure out what happened. So, oh yeah, I have negative values. So I said, that's why I did this part. If you have values less than 0, put them 0. So that's what I did. Look here, if I said if the depth is less than 0, put 0. Otherwise, put the same flood depths. So that's what I did here. And then, after I did everything in foot, I multiplied by 0.3048. So basically, I didn't have to do it in GIS. So I could have kept it as foot, and then it converted into meter, because I did the conversion here. All right, so that's for this one. Next part, right now, I'm ready, read the fragility, developed them, calculated the elevations. I'm ready to do the probability of exceedance of each damage state and the loss analysis. Okay, let's see how did I do it. Before you do any matrix analysis, you have to develop the matrix first. Like that's what we do in most of programming language. You prepare an empty matrix that you are gonna fill. Because if you let the software figure out after each step how much rows and how much columns it's gonna take more time. So that's why we prepare a matrix for the damage analysis and a matrix for the loss analysis and put every number as 0. Preparing the software, there is a lot of numbers are coming, just prepare a space for them. And we are gonna fill this matrix. If you didn't do this, it's gonna run, but it's gonna get more, it's gonna take more time. And I did this actually for many things out there. Like you put here, everything that I calculate, I prepare a matrix and I put zeros. And then I calculate the numbers here. All right, so I'm preparing a matrix that is gonna have, on the rows, is gonna have the F archetype. Like let's say the probability of exceedance each damage is gonna be 1, 2, 3, 4 until the number of buildings. Like let's say that we have 20,000 buildings, we're gonna have 20,000 rows. And on the y-axis, we're gonna have columns. This matrix has 5 columns. The exceedance probability of damage state 0, 1, 2, 3, and 4. That's the columns. The losses is just one number. So the y-axis or the column is gonna be one column. This building is building number 1, has 20% loss. Building number 3 has 30% loss. So that's what I'm trying to do here. All right, let's see how did I do it. After I prepared the matrix, I made a for loop. Since we are gonna do repeated process in many buildings, we have to create a for loop. And in this for loop, I said from building number 1 until the length of all the buildings. What is the length of F archetype? The thing is, if you go to F archetype, like if you go to the column here, let's look for F archetype. This column, this one, the length of this column is 93,897. Like if you go all the way down, you're gonna go all the way down to all the numbers. That's the length of it. So that's why I'm just preparing a matrix that has this length of this column. By the way, you can put the length of any of these columns. Like the thing is, I need the number of buildings. So actually, it turns out that the number of rows here is the same number of buildings. So that's what I'm trying to do. So I'm trying to do from 1 to the 90,000 whatever building, I'm gonna do the same process. So that's why I started a for loop. And then, for each one of these buildings, I'm gonna do damage analysis, but look what I did. I separated the analysis of damage state 1 and 3 from the rest of all the building archetype. Why? Because 1 and 3 has damage state 0. And basically, damage building archetype 1 and 3, I started measuring the flood depth from the ground elevation. Why? Because they are elevated and there is components here. I can't capture the components that are here if I started the flood depth from here. So that's why I start calculating the flood depth from the ground elevation. But if this building on a slab on grade foundation like this, I start from the first floor elevation, because the first floor elevation is close to the ground elevation. All the components start from here. There's no component below, right? So all the archetypes is gonna be the damage based on the first floor elevation, except 1 and 3, they are gonna start from the ground because there's components between the ground and the FFE. Here, look how did I reflected that. Look, I said here, if the archetype is equal to 1 or, this is or, 3, do this process. Calculate the probability of exceedance for building 1 and put here damage state 1, and then in column number 2, put damage state 2, 3, up to 5. Okay? For each building I interpolate, okay, this is interpolation, and this is 1D interpolation. If you go to the 3D function, 1 is gonna be 2, because you are interpolating X and Y. Right now we're interpolating 1D, and you are gonna read the depths. The thing is, if you are gonna interpolate in a function, this function, you have to select the, all right, you have to select the x-axis. Okay, like, let's say, this is how the interpolation function works. You have to give the interpolation function the x values and the y values so that it can use the original function, all right? Once you give it this, you have to give it what is the value that you want to find out the probability at. Like, let's say this function has the value of flood depths at 2 and 3. But the thing is, you want to find out at 2.4. So you give it the flood depths at 2.4, and it's gonna give you what is the value here. That's what I did. Look here, I give it the x-axis, which is the depth, and I give it the y-axis, which is the probability, okay? And by the way, the probability is a 3D matrix, okay? So the probability has for each archetype, for each damage state, for each what? For each depth. So that's what we have here. So I have here for each archetype. So basically, I put F archetype I because I want to change the 3D based on each archetype. So the 3D doesn't know, like, do you want to pick archetype 1 or 2 or 3? So I have to tell it. The thing is, this is keep changing based on what building that I'm dealing with. The thing is, like, if you go to the shape file here, you will find that this building is archetype 9. The shape file doesn't know. So you have to put it in the 3D matrix. So grab 9. But some are archetype 8, so it keep it changing once you go down. So you basically tell the MATLAB, if it's 9, put 9. If it's 8, put 8. Grab 8 from the 3D matrix. Okay. Let me close these figures. Close all. So we don't need them. All right. So I give x and y for the interpolation function. This is x, this is y, and this is the flood depth measured in meter. Okay, this is depths in meter, and this is depths. Okay. Let's see. This is called depths FFE, and I believe we read the depths in meter here. Okay. As I told you, we have the flood depths measured in meter. For archetype 1 and 3, this one, the flood depths I told you is going to be measured from the ground elevation. And that's actually what we directly extracted from the hazard map. Do you guys remember? We have the building, we have the flood depths, and once we extracted them, we extracted up. The number that we extracted is the flood depths measured in meter. But all the process that we have done here is to get the flood depths measured from the FFE. But the flood depths measured from the ground elevation, that's directly has been done. That's like we already extracted from the map. All this is to get the flood depths measured from the FFE. Like if you looked here, the final output for this one is the depths FFE. But these two archetypes, basically, they are measured from the ground elevation. So I directly put here the flood depths measured from the ground elevation. Other than that, if the building is not 1 and 3, if it's 2, 4, 5, 15, take the flood depths measured from the FFE, the one that we calculated, right? So that's these two. And once we are done with this, it's gonna calculate the probability of exceedance of each damage state. And be careful with exceedance. Exceedance, that means it goes all the way and calculate this, or here and calculate this, or here and calculate this is the exceedance. The probability of being in each damage state is this. This minus this, all right? We talked about this before. Let's get to the losses. The losses is doing the same thing. but we are using different function to interpolate from. Like look at this, we are using depths 2D, but we are not using the probability. Do you guys remember when I opened the Excel sheet that has the 15 columns? The 15 columns, this one. So I'm giving this the depths as an x-axis and the losses here as a y-axis for each building archetype. So basically I'm telling MATLAB, hey, go to the column that has depths 2D and to the matrix that has the loss 2D, and then for each depth extract the amount of flood losses. So I had a function like this. Let's not write this one. Like let's say this is the depths and this is the loss. And I have my losses as something like this. So basically I want this function to go here and interpolate and find the amount of losses. So I have to give it the depths, I have to give it the losses, I have to give it this value, and it's gonna give me this value. That's what I did over there. All right, so I did this for all the archetypes, and I'm gonna go down. Once I'm done, I calculated the probability of exceedance of each damage state. But what I wanna do, I wanna calculate a single damage state for each building. I wanna know at the end of the day, is this building slightly, moderate, extensive, or complete damage, right? I want one number, but to do this, I want to find the maximum probable damage state. The maximum probable damage state, we talked about this before, if you guys remember. We had this is the probability of exceedance, and this is the flood depths. And I'm going to have a curve, and another curve, and this is 1. Right? The thing is, let's say building number 8 is exposed to a flood depth of 3 meters or 2 meters, right? So I'm gonna calculate what is this value, what is this value, what is this value, what is this value, what is this value. Let's say this value was like 0.4, 0.35, 0.15, and 5.1. All right? I want to calculate all these values, and the maximum values of these is going to be the maximum probable damage state. So this is no damage. Let's say no damage. This is going to be damage state 1, damage state 2, damage state 3, and this is damage state 4. So the maximum probable damage is 40% to damage state 2. So at the end of the day, we're going to say that this building has the most highest probability to be damage state 2, because this is the maximum probable damage state. All right? So that's what I'm trying to do now. So how can I calculate from exceedance probability? Exceedance probability is different color. Exceedance probability is, that's actually what we got from this curve. Like all the numbers here, this is exceedance probability. What does it mean? It calculates, like let's say here, if you wanted the exceedance probability of damage state 1, it goes all the way up and tell you what is this all value. But we don't need all this value, we only need this from here to here. So you need to find the value here and the value here and subtract them to get this value. So that's what I'm gonna do next step. So look at this. I defined a new matrix. It's called the BN damage state. Means the probability in a damage state. And in this one, I'm gonna calculate 7 values. What are these 7 values? Okay, I'm gonna calculate the probability of no damage and the probability in damage state no damage. The probability in damage state 0, 1, 2, 3, 4. That's 5. That's 6 fields. And at the end, I want to know what is the final damage state. So I'm going to develop a function that is going to go through all these numbers and going to take the maximum and put it here. Okay? So that's why I have 7 numbers. But I believe I had 7. I didn't include the no damage one. Or maybe I had the no damage, but I didn't include damage state 0, something like that. We're going to find out. Because I have one that I was trying to find what is the maximum of them, and I put it in one single cell. And then the final I put is this maximum corresponding to what damage state, either 1, 2, or 3. Okay, let's see what did I do. All right, so define a function that has 7 columns and rows, 90,000 rows for the 90,000 buildings. And I calculate, you guys tell me, how can I calculate the probability of being in no damage? The probability of being in no damage here, like let's say I'm gonna make a line like this. This is the probability of having no damage. Can you guys tell me, how can I calculate this?
Subtract damage state 1 from 1.
Exactly, because this one is 1 here. So if I take 1 minus this value, it's gonna give me this value. But if I want this, I need to find out this and subtract them from each other. And that's what I did here. Look. Number 1 is like, I put ones in a matrix, like for the building I put 1, and then from 1 I subtracted the other damage state. So I made a matrix, a 1 matrix has the same size of the original matrix, and I subtracted 1s from the probability of being in damage state 2. So what I did here, I basically excluded damage state 1, damage state 0. Look, I started from 2. I did this so I can't confuse the process, but the thing is I can make it, like I can actually start like putting another damage state here and call it damage state 0. But the thing is it was only 2 archetypes. So I was like, okay, I'm gonna remove damage state 0, I'm not gonna complicate the process. But you can make this and add damage state 0. So what I did, I merged no damage with insignificant damage in 1 damage state. Alright? So that's what I did here. That's why I started from 2 and I neglected damage state, this one, this curve. Alright? Okay. But if you want to have it, you can have it. Okay. So then I calculated the probability of being in no damage, and then I did 2 minus 3. 2 means damage state 1. 3 means damage state 2. So that's damage state 1 and that's damage state 2. I subtracted this from this, is gonna give me the probability of damage state 1. Be careful because the numbers are 1 more than each damage state because we didn't have 0. So we started 1 means damage state 0, 2 means damage state 1. Remember that. Okay, and then I subtract 3 from 4, 4 from 5, and the last one, damage state 4, is the easiest one because the exceedance probability of damage state 4 is the same as the probability of being in each damage state 4. Because you basically subtract this from 0. Okay, so this one is the same, exceedance is the same like the probability of being in a damage state 1. Sorry, 4. Like look at this. If you want to find this one, you have to find the exceedance probability of damage state 4 minus 0. So I basically put this as is here, and I didn't put 0. All right, so right now I have the probability of being in each damage state. I want MATLAB to figure out what is the maximum of each one of these. So I made another function. Oh yeah, I was just doing something here. I was saying if a building has a probability of being in each damage state less than 0.001, make it 0. Because 001 is like nothing. So I can make the analysis process faster, right? So I'm making a threshold of the damage, just like organizing my matrices here, okay? All right, so I put zeros at the low damage areas, and then here I'm trying to find the maximum. Hopefully this, okay, let me run, what is the last one that we run? Did we run this one? Let's run this section. Okay, it says, it sounds like we didn't run this part. Alright, so this part is the part that calculates the maximum. Look what I did. I prepared, like here, I said, for all the numbers and the probability of being in damage state 1, and damage state, the probability of being in each damage state. So I have a matrix that has each building in the row axis, and I have damage state 0, 1, 2, 3, and 4. and I want you to check what is the maximum value of that. From 1 to 5, because 1 is the 0, 5 is the 4. Check the maximum. So he's gonna find the maximum, all right? He's gonna find the maximum value, but he's not gonna tell me what is the damage state corresponding to the maximum, okay? So that's what I'm doing here. I was trying to find which number is corresponding, like this is gonna find the position in each matrix. It's gonna tell me the maximum is at column number 1 or column number 2 or column number 3. So it's gonna find where's the maximum is matching from 1 to 5. The maximum is in 6. You guys remember, I have 6 columns. From 1 to 5 is the damage state. 6 is the maximum. Let's say, I'm gonna put it here, like I'm gonna 1, 2, 3, 4, 5, 6. Let's say this is damage state 1, 2, 3, 4, 5, and this is the maximum. So let's say damage state 1 is equal to 0.21, and this is 0.32, and this is 0.11, and this is 0.05. And let's count 53, 64, 69, and this is going to be equal to 0.31. And I want to find the maximum. When you find the maximum, what is the maximum of these? It's 0.32, but I don't want this number. I want what is the maximum damage state. I want to convert this. I want this cell to tell me that the maximum damage state is damage state 2. All right? So that's what this function is doing. It's trying to figure out where the number maximum in each one of these. So I want this to search until find here and then tell me that this is 2, but this is not damage state 2, sorry. This is in 2. I'm gonna put it 1, 2, 3, 4, 5, because 1 means damage state 0, as you don't wanna confuse you. This is damage state 1, and this is damage state 4, right? Okay, because the numbers is different from the names. So when it finds this in cell 2, I'm gonna ask to subtract 2 minus 1, and it's gonna give me 1, and it's gonna tell me here damage state 1. All right, so that's what I did here. Look, once it's find, subtract 1, and once you subtract 1, that means it's gonna tell me directly this is damage state 1, 2, or 3, right? Okay, so I know that our time is done. At the last one, I'm just writing the new shapefile. So I'm done. I calculated the probability of exceedance each damage state. I calculated the probability of being in each damage state, and I found the maximum. Right now, I'm trying to write a shapefile that has all these numbers. Look, the probability of exceedance from damage state 0 to 4, the probability of being from damage state 0 to 4, and the building maximum damage state, the building damage state, and the loss at the end. I'm writing all the results that I have, and then I'm generating a new shapefile with the new results. So we are done with the damage analysis. Once it's done, you can take this shapefile, drop it in ArcGIS Pro, and you can visualize the analysis. Next time, we're gonna have a hands-on MATLAB and try to do all this by ourselves. So try to bring all your laptops, make sure that you have MATLAB, make sure that you have ArcGIS Pro, and we are gonna do this and see what problems that we have. And start doing it in your home at first, and then we discuss what issues that you have, right? Okay, see you guys next time, and sorry for the 4 minutes.